Hello everyone. Welcome to our channel. I'm your host, Zebody. The topic of this video is the road to artificial superintelligence. Artificial superintelligence, or ASI as it is called, is the final frontier of synthetic intelligence or non-biological intelligence. We've been fascinated by AI technology, how it is shaping our world, where it's headed, and its impact on society. In the past 50 years, computation speeds, new content creation, spread of information and knowledge, and the applications of useful knowledge transformed our world into one large global interconnected and intertwined commercial and social web. In just the last 3 years, the arrival and the subsequent rise of artificial intelligence has been tremendous, and AI large language models, or LLMs as they are called, trained on mountains of data, can write stories and poetry. They can create research papers, create images, videos, music, perform translations, and transcribe audio on the fly. In recent months, multimodal capabilities in LLMs allow them to clone and mimic humans right up to physical appearances, voice, and even facial expressions. Cloned humans, or digital twins and avatars, are increasingly encroaching and blurring the lines between reality and fiction. Nothing is going to stop the progress of the evolution of this synthetic intelligence. Why? Because of the human nature to compete and consistently prioritize power and wealth concentration over collective well-being of humanity. With AI, the stakes are very high, as AI could be humans' last invention. Competition is expected to be fierce among the players in the race to develop and control the most powerful AI entities, and whoever wins shall rule the world and all humans for centuries to come. The quest for advanced artificial intelligence has become an irreversible force, with its development driven by intense competition among nations and corporations. This technological arms race ensures AI's continued evolution towards superhuman capabilities, while economic and political power structures suggest that this transformative technology will likely remain concentrated in the hands of dominant nations and elite groups rather than being democratically distributed. The early forms of artificial intelligence, this is up until 2022, can be viewed as baby AI. This we call artificial narrow intelligence, or ANI for short. ANI is also known as weak AI in the industry. For our purposes, we'll call ANI level 1 on the intelligence scale. ANI is designed for specific, narrowly defined tasks. What makes ANI distinct is its specialization. It excels within strict boundaries and cannot transfer knowledge between domains. For example, AlphaGo can defeat world champions at the ancient Chinese game Go, but cannot drive a car or write poetry. Other examples of weak AI include image recognition systems that can identify objects with incredible accuracy, natural language processors like spell checkers, recommendation engines on social media and streaming platforms, industrial robots programmed for specific manufacturing tasks, etc. The key limitation is that ANI systems cannot adapt their learning to new contexts or tasks outside their training, pretty much similar to a child who can only do what it's been taught and trained to do. And one major advantage that ANI has over humans is that it never dies, and all the collective knowledge it has gained from other neural networks is preserved for the next generation or level. The next level up from ANI is Artificial Capable Intelligence, or ACI. This is level 2 for our purposes, and AI entered this realm in early 2024. Please note that these levels are not set in stone. The exact definitions are debatable due to the many unknowns and the novelty of this dynamic and rapidly evolving technology. So in our case, level 2 is ACI, and it refers to AI systems that have reached a level of a college-going adult. They can successfully apply their capabilities in relevant situations and achieve goals effectively. This level of AI is distinct from possessing raw computational power or trained abilities alone. ACI emphasizes the importance of an AI's ability to appropriately deploy its skills across different contexts and actually accomplish intended tasks, such as managing a back office, managing a call center, etc., which means that it can call upon other AI agent experts for assistance. Basically, you can imagine an ACI as a somewhat experienced person on your staff who has broad skills and is capable of limited agentic decisions within the confines of a domain or project. While ACI can perform a broad range of tasks without supervision, it does require guidance and supervision on the more complicated tasks and decisions. In addition to the above attributes, ACI can also be described as an AI that has limited emergent properties. This is attributed to the fact that besides increase in scaling of computational power and data size, many new advanced technologies have emerged for advancing reasoning and thinking capabilities of LLMs. Some of these are Q-star, multimodal models of mixture of experts, or MOE, mixture of expert AI autonomous agents, retrieval augmented generation, or RAG, algorithms for generating synthetic training data, reinforcement learning, chain of thought reasoning, AI agent frameworks, algorithmic efficiencies, advanced computer vision, and a few other cutting-edge technologies. Collectively, there has been orders of magnitude quantitative improvements in 2024 resulting in new and unbelievable breakthroughs in AI. By the way, many of the mature AI models in use today such as GPT-4o and GPT-01 from OpenAI, Claude 3.5 from Anthropic, Gemini 1.5 from Google, Llama 3 from Meta, and a host of others are almost at or near the ASI level. These models are capable of working in swarms to achieve tasks that only seemed impossible just a few months ago. Also, don't be surprised if some of these ASI-level models have been tasked to break the barriers for reaching the next level, which is Level 3 or Artificial General Intelligence, or AGI. With AGI, we've entered the danger zone. AGI represents an extraordinary and significant leap forward. It would possess human-like general intelligence and cognitive capabilities. The distinguishing features of AGI would include the ability to transfer knowledge between different domains, the capability for abstract reasoning and problem-solving across various contexts, self-improvement and learning from experience, understanding and generating natural language at human levels, and, possibly, consciousness and self-awareness, though this remains debated. Currently, there is considerable debate about when or if AGI might arrive, with estimates ranging from years to decades. But looking beyond speculation, let's examine the technologies that have emerged and are converging rapidly to break the AGI barrier. We're not talking of AGI with human-like consciousness, but simply AGI with extreme intelligence and perhaps its own unique synthetic awareness and consciousness. The quest for artificial general intelligence is one of the most challenging and ambitious goals in the field of AI. While we have witnessed remarkable advancements in narrow AI and more capable AI systems, achieving AGI requires a confluence of several key developments and breakthroughs across various domains of AI technology. The road to AGI is becoming exciting, and billions of dollars, if not trillions, are being invested in the quest for AGI because the rewards for the winner are staggering. There are just a few main fundamental paths being pursued and approaches currently being experimented that can provide the jumping-off points for AGI evolution. Let's go over the top 5 contenders. The first approach is RGMs, or Renormalizing Generative Models, from Karl Friston and colleagues of Versus.ai. Friston is known for his work on the free energy principle and active inference. His core approach centers around the free energy principle, or FEP, which proposes that biological systems minimize their variational free energy. Active inference, which describes how agents can minimize surprise through action and perception. And hierarchical predictive processing, where the brain builds generative models to predict sensory input. Karl Friston's work is augmented by a novel idea from a company called ThemeSys, where they use both signal and symbolic, knowledge graph or ontology, representations and a means for connecting these two representations, that is signal to symbolic connections, via something they call a corticon, or content-retentive, temporally connected neural network. The second approach is H-JEPA, or Hierarchical Joint Embedding Predictive Architecture, from Yann LeCun and colleagues at Meta. This architecture aims to understand and predict the world more efficiently by focusing on abstract representations rather than precise details. Unlike traditional models that try to predict exact future states, H-JEPA uses a hierarchical system to encode observations into increasingly abstract representations and then predicts how these abstractions might change over time. The architecture combines an encoder for converting observations into abstract representations with a predictor for forecasting future states, all while using joint embedding to represent both current and potential future states in the same abstract space. This approach is designed to be more efficient and closer to human-like reasoning, potentially leading to better understanding of cause and effect relationships. The third approach is called Cognitive Synergy by Ben Goertzel of SingularityNet. Ben is combining multiple AI methods, that is symbolic logic, neural networks, and evolutionary algorithms, rather than relying on a single approach. It is a bio-inspired architecture that aims to replicate aspects of human cognition and consciousness. Ben Goertzel's approach of cognitive synergy is the neurosymbolic approach. Neurosymbolic AI combines neural networks with symbolic reasoning systems. Neural networks handle pattern recognition and learning from data. Symbolic systems manage logical reasoning and explicit knowledge representation. The 4 main features of neurosymbolic AI are representation, learning, reasoning, and decision-making. This hybrid approach aims to overcome limitations of pure neural or pure symbolic systems by leveraging knowledge graphs and enabling both data-driven learning and formal reasoning capabilities. The fourth approach is immensely scaling up of LLMs, or large language models, and variations on that theme with deep reinforcement learning, Q-star, mixture of experts, mixture of depth, A-star, the pathfinding and graph traversal algorithm, and variations on that theme. Many large players such as Google, Microsoft, OpenAI, Anthropic, Amazon, Tesla, and NVIDIA, among others, are working on the LLM approach. It is generally understood that the solution in the LLM's approach is not to add more connection weights or to increase the context window size or increase the size of the learning data corpus and compute. Rather, it is to create a connection between the signal processing capability that is offered by transformers and an ontological knowledge-rich representation. Google's secret weapon is their existing knowledge graph, which is the largest and most carefully developed ontology. When Google can connect their knowledge graph to their transformer-based generative AI systems, they'll occupy a unique niche in the AI world and perhaps create the first real AGI. And finally, the fifth approach is the Badger architecture, a framework developed by Good AI that focuses on modular lifelong learning. The system operates through a network of identical agents or experts that can adapt to new and unseen tasks while retaining and reusing previously acquired knowledge. The architecture's key advantage lies in its modular approach, which enables better scaling than monolithic systems, and its focus on lifelong learning allows for incremental learning with reduced training data requirements. It is also likely that a combination and a mixture of these five approaches gets us to the desired goal, as they are all complementary in nature. So if and when AGI levels are achieved, it would be a huge milestone, as humans, for the first time, will have a non-biological and competing intelligence on our planet. Something totally alien to contend with. How far out is true AGI? We can only guess. And the guess ranges from between 5 years to maybe 20 years? We'll share with you the most recent predictions from various experts regarding the timeline for achieving artificial general intelligence, AGI. Several prominent figures in the AI field foresee AGI arriving within the next few years. For example, David Shapiro suggests AGI could emerge as soon as October 2025, basing his prediction on factors like major industry investments and emerging tools. Dr. Alan Thompson projects AGI by June 2026, while Demis Hassabis of Google DeepMind anticipates AGI with human-level cognition within the next few years to maybe within a decade. OpenAI's Sam Altman, though not providing a specific date, implies AGI's arrival in the near future through his urgent calls for oversight and regulation. Anthropic's Dario Amodei suggests AI reaching a well-educated human level could happen in 2 to 3 years, while Ray Kurzweil predicts AGI by 2029 or sooner, citing exponential growth in computing power. And Gary Marcus argues that AGI is still decades away. Marcus emphasizes that comprehension, reasoning, and ability to handle novel situations is difficult for software code to achieve. Whenever AGI arrives, we're going to have a machine consciousness with an ego, a sense of self, possibly as smart as us or smarter, certainly able to think faster and more precisely in many ways, and with unlimited growth potential because self-improving, code-writing AGI leads inevitably to superintelligence. That's the real ticking time bomb. Once we've overcome the AGI hurdle, achieving level 4, which is artificial superintelligence, or ASI, is as easy as a walk in the park. Why is that? Because if you use the same analogy that we used earlier, that is of the top scientists working in collaboration to solve problems, you can expect AGIs working to develop ASI. Imagine hundreds and thousands of AGI perfectionist Nobel laureates working in collaboration with quantum computers at their disposal to develop ASI very rapidly. AGI swarms will either build fully functional, decoherence-proof quantum computers or figure out very quickly on how to simulate quantum bits, or qubits, behavior on classical computers and have access to quantum parallel computing power. So the AGI to ASI jump could be a matter of months, if not weeks. When AGI surrenders to ASI, we would have synthetic intelligence that would surpass the most intelligent human capabilities across virtually every domain. Oxford philosopher Nick Bostrom defines it as an intellect that is many-fold smarter than the best human brains in practically every field. ASI would theoretically possess vastly superior memory, processing speed, and analytical capabilities, ability to solve complex problems beyond human comprehension, potential for recursive self-improvement, a sense of self-preservation and survival, advanced scientific and technological innovation capabilities, and understanding of concepts that humans might not even be capable of grasping. Finally, assuming that artificial superintelligence emerges, what form do you think ASI will take? What will ASI look like? We don't mean in physical form, but we mean its soul, which is going to be gazillions of lines of sophisticated, unreadable, and obfuscated computer code distributed among thousands of unidentifiable computers all over a global network. Somewhere within this codebase will be its ethos, that is its fundamental character, its moral nature, and its disposition and guiding beliefs. Just as humans develop beliefs, habits, and a personality from their childhood as part of their upbringing and grooming, ASI will have evolved in a similar manner, learning from what it has been taught and what it sees and observes. What AI learns from humans today will form AGI's nature and personality, which subsequently its successor, ASI, will adopt as its nature and personality. ASI would have a mind more powerful than all humans combined and will be able to do thousands of quadrillions of computations per millisecond. In an extreme case, be able to subtly manipulate the minds of billions of people while parsing every possible cause and effect, every scenario, however implausible, into a very real map of a most probable next. As artificial superintelligence advances rapidly, accelerated by existing AI capabilities, we must act with foresight. Our responsibility lies in balancing technological progress with human values. Through ethical governance and wise stewardship, we can shape an AI singularity that enhances rather than diminishes humanity, creating a future where technological advancement and humans flourish and evolve in harmony. Thanks for watching. We hope you found the material informative and thought-provoking.